Welcome back to our blood work lecture series. Today we're going to discuss how to interpret a lipid panel. This one's really important to know because the lipid panel is one of the most commonly ordered blood work tests and is clinically useful because it assesses risk for cardiovascular disease, diabetes, stroke, etc. But before we even start talking about the lipid panel, we need to talk about lipoproteins. What are lipoproteins? They're basically fat globules wrapped in a water-soluble membrane. All this useful fat here, it needs to get around the body to body tissues. But the problem is that lipids are not soluble in water. So to travel in the bloodstream and get around the body, they have to be broken up into small particles and wrapped in a membrane. There are four basic building blocks we need to know. Triglycerides, cholesterol, phospholipids, and apolipoproteins. So triglycerides are going to be on the inside of a lipoprotein because they're lipid soluble. They're made of three fatty acids stuck together and as such are mainly used as an energy source. Cholesterol is a large, flat, lipid-soluble molecule. It's used as a component of cell membranes and as a precursor to certain hormones. So here, it's not pictured, but it's going to be found either in the lipid-soluble interior or embedded in this membrane. So phospholipids are really important to talk about, so we'll go to another slide real quick. So the big thing with phospholipids is that they form the membrane of not just cells, but other structures too. So their big deal is that they're amphiphilic. They have one side that's water-soluble, seen with these white circles here, and one side that's lipid-soluble, seen with these yellow tails stuck together here in this bilayer sheet. They're the main component of cell membranes, so in that context you may have heard it called the phospholipid bilayer. But it's also used in other structures too. So for example, if a cell outpouches part of its cell membrane and encloses part of the interior cytoplasm, we call that a vesicle. So there's going to be an aqueous solution out around here, and then there's going to be aqueous material inside here. But smaller still are going to be something called micelles, which have a phospholipid monolayer. That is just one layer thick. And on the interior is going to be lipid-soluble material because that's where the lipid-soluble tails are all pointed. Micelles, that is what lipoproteins are. So when you look here, you can see the phospholipid monolayer with the water-soluble portion pointed outside and then the lipid-soluble portion pointed inside, right against all these lipid-soluble triglycerides. And finally, apolipoproteins are amphiphilic proteins that are embedded in the surface of lipoproteins. So in this diagram here, the hydrophilic portion is going to be on the outside here, and the lipid-soluble portion is going to be on the inside here. So now that we've gone over the components of lipoproteins, which are triglycerides, cholesterol, phospholipids, and apolipoproteins, now we can go over the different types of lipoproteins. So the major lipoproteins are chylomicrons, VLDL, which is very low density lipoprotein, LDL, low density lipoprotein, and HDL, high density lipoprotein. And you can think of them as existing on a continuum from big to small, less protein to more protein. So the apolipoproteins are represented by these green dots here, and as you go in this direction, they're going to have more and more apolipoproteins. They go from more triglycerides to less triglycerides, so that's represented by the yellow color here. So you can see that chylomicrons are mostly triglyceride, VLDL has a lot of triglyceride, LDL has a little bit, and HDL has barely any at all. And then they also go from less cholesterol to more cholesterol, but only up until LDL, because when you go from LDL to HDL, the cholesterol content actually drops because it's mostly apolipoprotein. So you can see here chylomicrons have very little cholesterol, VLDL has some, LDL is mostly cholesterol, and then HDL goes back down to having some cholesterol. So now let's see where the lipoproteins come from. So as we know, lipids are absorbed in the gut from food. There are many different things that qualify as lipids, but the main ones we care about are triglycerides and cholesterol. The cells lining the intestinal tract absorb lipids and package them into those tiny particles we were talking about called chylomicrons. Chylomicrons circulate around the bloodstream and deliver triglycerides and cholesterol to body tissues. Once most of the triglycerides have been delivered to body tissues, the chylomicron remnants are absorbed into the liver. The liver repackages some of the triglycerides and cholesterol as VLDL, which is mostly triglycerides but still contains some cholesterol. VLDL goes around to body tissues and delivers triglycerides, and over time the cholesterol becomes more and more concentrated, and what you're left with is LDL, which is mostly cholesterol. It's not useless, as it does deliver cholesterol to body tissues, but the problem is that because it contains a lot of cholesterol, it has a tendency to stick to atherosclerotic plaques and contribute to atherosclerosis, which is why it's known as the bad cholesterol. The liver also produces HDL, high-density lipoprotein. Unlike the other lipoproteins, its primary purpose is not to deliver lipids to body tissues. It's actually the opposite, to absorb excess cholesterol, which is why it's known as the good cholesterol. Its primary component is not lipids, it's those apolipoproteins. I prefer to think of it as a cholesterol sponge, going around and soaking up excess cholesterol, although it does also do a similar job to LDL in that it delivers cholesterol to body tissues. But once it's absorbed enough cholesterol, it goes back to the liver to deliver that excess cholesterol, so the liver can do other things with it, like package it into other VLDLs. So real quick, just to summarize everything we learned about lipoproteins, as you go from chylomicrons to VLDL to LDL to HDL, they get smaller and smaller. Their apolipoprotein composition gets higher and higher. Their triglyceride content goes down, and their cholesterol content goes up to the LDL, and then it drops down in HDL. Now that we're familiar with the lipoproteins, we can talk about how a lab goes about doing the lipid panel. So, before we move on to the lipid panel components, I want to take a moment to discuss how a lab actually does a lipid panel, because that'll be important to understanding part of the lipid panel components. So let's take a quick look here back at a slide we were just looking at. So, it would be prohibitively expensive if labs had to individually look at the levels of chylomicrons, VLDLs, LDLs, and HDLs. So what they do is instead take a kind of shortcut. So imagine that the lab puts all of the blood in a blender, and it breaks up all the components of all these lipoproteins so that you get all of these triglycerides all together from here, and here, and all the cholesterol gets pooled together here, and here. That's basically what the lab does to find the total levels of triglycerides and cholesterol in the blood, respectively. And then it uses those values to calculate the values of some of these lipoproteins here. The only one that it directly measures is HDL, and it uses that to calculate the values of VLDL and LDL. Alright, so now we've gone over lipoproteins, all the different components and the different types. We've gone over how a lab does a lipid panel, measuring the total triglycerides, the total cholesterol, and the HDL, and then it calculates everything else from those three measurements. So now we can finally talk about the lipid panel components. So let's go ahead and start at triglycerides here. And those are mainly used for energy or for energy storage, so like in adipose tissue. As we talked about, they're carried primarily in chylomicrons, but secondarily in VLDL, but most of it is in the chylomicrons. This is the reason they say fast before a lipid profile, because eating can cause short-term elevation of these guys. However, they're finding the fluctuations weren't as big as initially thought, so now they say you don't have to fast unless you really need an accurate number for like medication adjustments. Most of the time, high trigs are caused by a poor diet and lack of exercise, but sometimes it's secondary to another issue. So for example, in diabetes, the body it no longer becomes good at using glucose as an energy source, so it starts to turn more towards triglycerides as an energy source. So you start to see a lot higher circulating levels of those. You might also see it in hypothyroidism, because if you slow the body's metabolism, it's going to be burning through less of these triglycerides, so that's going to kind of build up. And so this triglyceride measurement, that's a good general indicator of cardiovascular risk, but not as much as some of these other things, which we're going to talk about in just a second. So next is total cholesterol. And again, this is cholesterol that's kind of been blended together from all the different lipoproteins. So chylomicrons, VLDL, LDL, and HDL kind of all put together. So for that reason, it's not as high yield as the other tests because it doesn't differentiate between the different types of cholesterol, or rather the different lipoproteins. So generally speaking, lower is better, but that's probably more to do with it signifying lower LDL levels, because that's the bad cholesterol. HDL, as we talked about, is known as the good cholesterol. It primarily goes around and picks up excess cholesterol, and generally speaking, higher levels are better. So VLDL, this is where we get into the calculated values that we were talking about. And again, they primarily carry triglycerides, and they are not measured directly, but instead you calculate them as 20% of the total triglycerides, and then the other 80% of triglycerides are carried in those chylomicrons. So therefore, clinically treat it the same as you would high triglycerides. So if there's a medication that treats high triglycerides, that's also going to treat high VLDL. So now we go on to LDL calculated, and that the LDL primarily carries cholesterol, as we talked about, and it's calculated by taking the total cholesterol minus HDL minus the calculated VLDL. And this is the important one because of all the lipoproteins, this has the strongest correlation with cardiovascular disease. Now, you might be asking yourself, well, HDL is a good cholesterol and LDL is a bad cholesterol. Couldn't a high level of HDL kind of cancel out LDL? And that's what the cholesterol-HDL ratio attempts to do. So it's the ratio of total cholesterol to HDL cholesterol. And so a higher level of HDL could compensate for high levels of LDL, but only within a certain limit. So it's a slightly better predictor of cardiovascular risk than just the LDL alone. But even better than this is the non-HDL cholesterol. So you can find that by taking the total cholesterol minus the HDL, as would be implied by the name. And that's going to equal VLDL plus LDL. But again, this is calculated as 20% of triglycerides, so it's basically that plus LDL. And this is a good one-number general indicator of cardiovascular risk because it incorporates both triglycerides and LDL, which is the bad cholesterol. And some researchers now believe that this may be more useful than both the LDL alone and even the cholesterol to HDL ratio. And so that is what's typically going to be included in a lipid profile. Now, if there's a patient you're particularly concerned about, or you're thinking about a medication adjustment, you might order a lipid panel plus Reflex Direct LDL. So if you remember, Reflex means that the lab ordinarily won't do this measurement unless a certain criteria is met. And this triggers when triglycerides are greater than 400. This is helpful because it measures LDL directly instead of calculating it from other values. So it's going to be a lot more accurate. So you're going to want to get this when a more accurate level of LDL is needed, such as when you're adjusting a patient's cholesterol modifying medications or lipid modifying medications. And we're going to talk about these in just a moment. So now that we have a good idea of what the lipid panel is all about, it might be a good idea to real quickly go over some hyperlipidemia medications because these are medications you might be considering based on the results of the lipid panel. There's medications for high triglycerides and for high cholesterol, but there's a fair bit of overlap between the two, as we're going to see. So to start, let's talk about statins. They are primarily known as a cholesterol medication, and they primarily decrease cholesterol, but they can also decrease triglycerides by causing the liver to absorb more triglycerides, so there's going to be less in general circulation. Another one is fibric acid derivatives, and those cause cells to burn and absorb more triglycerides. That's body tissues in general. But the problem with these guys is that it's generally not advised to take these with statins, and statins have a better record of actually causing clinical health benefits like a reduction in myocardial infarction rate. So you're going to use these in the relatively rare cases where a patient's LDL is not too bad, but they have really high triglycerides. The next up is niacin. That reduces adipose tissue release of fatty acids, so there's less in circulation, reduce liver production of triglycerides, and that reduces the liver production of VLDL because the liver is producing less triglycerides to package into the VLDL. But there's some problems with this. It sounds like it does a lot of good stuff, as you see up in here, but it has to be taken at high doses to be effective, high enough that they can cause liver damage. And it causes this uncomfortable, warm red flushing of the skin. So this is what's known as an empty stats medication. So even though it improves numbers of reducing triglycerides and cholesterol, clinical trials have not shown an actual clinical benefit in terms of reducing risk of myocardial infarction or stroke. So for these reasons, the use of niacin has fallen out of favor over time. And next up is the omega-3 fatty acids, otherwise known as fish oil. It can come from other sources too. And in addition to their well-known anti-clotting and anti-inflammatory effects, they are also mild competitors of triglyceride synthesis, particularly in the liver. But studies have shown that the benefits are milder than initially thought. This is kind of an optional medication. If the patient is interested in trying it, it's fine, but it's not quite a must use. And last but not least, there are the medications for high cholesterol. There's a bunch of different classes, but the big one you need to know is statins. Those reduce liver synthesis of cholesterol. That's actually the main source of cholesterol that gets packaged in VLDLs and ultimately in LDLs. And these are well studied and well documented in terms of their benefits in reducing the risk of MIs. And next up, you have bile acid sequestrants. So, as you know, cholesterol is excreted in bile and is reabsorbed in the intestine. So this medication reduces the reabsorption of bile from the GI tract, allowing cholesterol to be excreted in the stool. Next up is ezetimibe, and that reduces GI absorption of cholesterol from food. Both bile acid sequestrants and ezetimibe act on the GI tract, and they both cause cholesterol to be excreted in the stool. And then next up is fibric acid derivatives and niacin. We talked about those up above in the previous section here, and their main benefit for reducing cholesterol is reducing liver synthesis of triglycerides, so that means less VLDL is produced, etc. And finally, omega-3, again, same mechanism. It slightly reduces liver triglyceride production, which leads to a slightly reduced VLDL release, and that means less cholesterol circulating in the circulatory system. So that does it for this lecture on the lipid panel. We'll see you in the next one.